Good morning children. Today we are going to study about what happens when metals and non-metals react, how it will react, why they react like that, while reacting what are the things which are going to happen we are going to see. Okay? How do metals and non-metals react we are going to see. In your 9th standard you have studied about electronic configuration. What is electronic configuration? Based on how the electrons are rotating around, we have studied, right? For example, noble gases we will see. Noble gases, I told you, the last group in the periodic table, we will study helium, neon, argon, krypton, xenon, radon and all. We have also studied about why they are called as noble gases, because they maintain the stability, that is the outermost shell. Outermost shell in the sense you have studied many shells, no? For example, you have studied K shell, K, L, M, N, I think. No, K, L, M, N you have studied. So when you are studying about elements or metals, you have studied that electrons will be rotating around and the last shell is called as valence shell, right? Okay. Now we will see just a recap of what we have studied in 9th standard. Okay, so it will be easy for you to remember. Helium, the atomic number is 2. How will you split this 2? In K shell you will have 2 electrons. Okay, in K shell you will have 2 electrons. But you know that noble gases are maintaining the stability. Helium is having only 2 electrons. Duplet. Okay. This is an exception that helium will have only 2 in the outermost shell. All other elements, all other noble gases, if you see, they will have 8 in the outermost shell. See, for example, neon. Neon's atomic number is 10. How will you split it? 2, 8. 2 in first shell, K shell, and 8 in the L shell. So, in this, which is the valence shell? L shell is the valence shell. Okay, it will be having 8 in the outermost shell, so it is stable. It will not react with other elements. Okay, argon. Argon's atomic number is 18. See here the same way if you split 2, 8, 8. It means this is K shell, this is L shell, this is M shell. Here which is the valence shell? M shell is the valence shell. Here first one K shell. Here K and L, but L is the valence shell here. 8 electrons will be seen in the outermost shell. Argon, you have 18 atomic number, you are splitting it into 2, 8, 8. And the last shell is called as the valence shell, which is having 8. Krypton. Krypton's atomic number is 36. How will you split this 36? 2, 8, 18, 8. Okay. So this is K shell, L shell, M shell, N shell. So N shell, the last valence shell will be having 8. Same way here also it goes on like that. Now you will have a doubt. Why 18 here? It should be 8 now. So alpha principle. See, this is alpha principle. In this they will explain clearly about the orbitals. Subshells. Okay, orbitals they will explain. How it is explained using S, P, D, F. Okay. S shell, P shell, D shell, F shell. S, P, D, F. S will always have 2 electrons. P will have 6 electrons. D will have 10 electrons. Maximum it can hold 10 electrons. S can hold 2 electrons. P can hold 6 electrons. D can hold 10 electrons. And F can hold 14 electrons. See, for example, I am writing neon. Okay. Neon, this is the element. First shell. Neon's atomic number is 10. So 2, 8 times splitting. So one shell. This K shell is also there. One more I should put. Which shell? This is L shell. In K shell it can hold how many electrons? 2 electrons. In L shell it can hold 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons. Okay. So this is how it will be moving around. Now argon 18 means what will you do? One more you will draw and you will show 2, 8, 8 in that shell also. Here is it S orbitals p orbitals, d orbitals and f orbitals. Okay. When you are writing like this, see s we should put 1s, 2s, 3s, 4s, 5s, 6s, 7s. P 6, 2p, 3p, 4p, 5p, 6p, 7p. 1p is not there. Okay. D 1 and 2 is not there. 3d, 4d, 5d, 6d. 7 is not there. This you will study in your high school, in your college. Okay. Now this is just to tell you how it is coming here in the configuration I am explaining. F also only 2F, 4F and 5F. See here, they have put a line like this. This is 1S, this is 2S, then 2P and 3S, 3P and 4S, 3D, 4P, 5S, 4D, 5P, 6S. See the lines, how nicely it's coming. 4F, 5D, 6P, 7S, 5F, 6D, 7P. Okay. Now, after 1 years, it will come and correct here. After 2 years, it will come and correct here. After 3 years, it will come and correct here. After 4 years, it will come and correct here. 5 years, it will come and correct here. 6 years, it will come and correct here. 7 years, it will come and correct here. So when you are writing now, see for example 2, if I am writing 1s2. Okay, I will write it as 1s2. For neon, if I am writing 1s2, 1p and 2s. 1s2, 2s2, 2p. The next one. Because this is 2, this is 2, this is 6. Here 10 should come, no, total. See here, 10 total. This is 2s. Okay, 2. S will have always have 2. P will have 6. Maximum it can hold 2 electrons, P can hold 6 electrons, D can hold 10 electrons, F can hold 14 electrons. Okay, now if I am writing for argon, I should go till 18. This is 2, this is 2, 4, this is 6, 10, 11, 12, 12 plus 6, 18. So till here I should come. So it comes like this. Okay. So when you are counting like that, you will get 18 also. After while counting like that, we will get 32 also. See here, this is only S. Okay. This is S and P. How many it is there in this shell? You will get 2. In this you will get 6 plus 2, 8. In this 2 plus 6, 8. 8 plus 10. So 18. When it comes to the next one, it will be 18. 4S you see, S is 2, P is 6, D is 10, F is 14. Count all. 2 plus 6, 8. 8 plus 10, 18. 18 plus 14, 28, 29, 30, 31, 32. 32. Like this it goes on. Okay, this is how we are getting 18, 32 and all. You will study it in your higher classes. It is very nice, no? How it is given, alpha principle. So here you just want to know how this is divided. This 2 how it is split, this 10 how it is split, like that we should know it. This is stability is maintained in the last valence shell. Here it is 2, here it is 8. Here it is duplet, here it is octet. Now in metals. Okay, in metals how it is happening. Our aim is to study what happens when metals and non-metals react. In metals you see sodium, the atomic number is 11. How will you split it? 2, 8, 1. Magnesium 12, 2, 8, 2. Aluminium 2, 8, 3. Then potassium 2, 8, 8, 1. Calcium 20. So 2, 8, 8, 2. Okay. How many shells will be there here? 3 shells will be there. We will write sodium. Sodium, 1 shell. In the first shell you will get 2. In the second shell you will get 1, 2, 3, 4, 5, 6, 7, 8. In the third shell you will be having 1. Same way in magnesium you will get 2 in the outermost shell. In aluminium you will get 3. In potassium you will get 1. In calcium you will get 2. By studying this, you will come to know that they have extra electrons in the outermost shell. Right? This is 8. Extra electron is there. So surplus electron, more than what is needed, is there in the outermost shell. What they will do? They will lose electrons and they will become, I told you, no, cation. Okay, they are giving and they will become cation. Okay, they will get the positive sign. So whenever you are writing sodium ion, how will you write? Na plus. They will always get a positive sign there. We will check in non-metals how it is happening. Okay. In nitrogen, the atomic number is 7. How will you split? 2, 5. Oxygen, 8. How will you split? 2, 6. Fluorine, how will you split? 9, 2, 7. Sulfur, how will you split? 2, 8, 6. Chlorine, 17. Atomic number is 17. So you will split it as 2, 8, 7. Okay. So in this, if you see, for example, chlorine. We will take chlorine. How many shells chlorine will have? 3. In the first shell it will have 2. In the second shell it will have 8. 1, 2, 3, 4, 5, 6, 7, 8. Third shell you will get 7. 1, 2, 3, 4, 5, 6, 7. Okay. So here one is extra. Okay, they have surplus electrons. Here they need electrons. See, 7 are there in the outermost shell. If they get 1 electron now, they can maintain the stability. Right? Here it is extra, here it is less. So what will they do? They will go for a bond. Okay, these two will come together. This will give 1 electron and this will get 1 electron. So there is a bond between metals and non-metals and that bond is called as ionic bond. See? Ionic bond. Okay, the bond. What will happen now in this bond? Exchange of valence electrons takes place. Valence electrons means electrons is present in the outermost shell. See, the next shell now they are not doing anything. Only the outermost shell. This is K shell, this is L shell, this is M shell. Here also K shell, L shell, M shell. K shell is not doing anything. L shell is not doing anything. Only the M shell will get 1 electron. Same way here, K and L they are not doing anything. Only M shell will give 1 electron. So it's very important that exchange of valence electrons takes place, but not in the other shells. Only in the outermost shell, valence shell, they will try to have a bond. That bond is called as, what's the name? Ionic bond. So tomorrow we will be studying in detail about what is ionic bond. I think it's clear now. You check this, study, write it and then check with the other notebook. Okay, don't just read it and leave it. Here it is noble gases I have given. How the electronic configuration now will be. To make you understand this one, I have given the upper principle. And then in metals how it happens, some examples I have given. In non-metals some examples I have given, and they will have a bond. Okay, they will combine together with the help of a bond, and that bond is called as ionic bond. We will be studying about ionic bond in the next class. Bye.